But anyway, but I'll let you know like as we're getting closer.
Yeah, of course.
Good. All right, so let's get started. So we're
Yeah.
going live. Yes, going live. We're getting a lot of good comments already in the chat. This is awesome, solid energy. Hello, everyone. Welcome to live stream number 86.5, because this one's a little bit off the charts. Very, very good to be here with everybody today. Already nice to see all the energy going in the chat. This is what we want, all right? We want your comments. We want your questions. We want your suggestions. One thing that I will leave in the chat before we get started, we will be having a co-located event in KubeCon on October 12th, all right? I will leave the link for that here so you can register already. It's totally free. We will also be having the DoK Students Day on October 6th, all right, the week before. So if you are interested in giving a talk, even if you're a total beginner when it comes to data on Kubernetes, please jump in our Slack. We've started a thread in the beginner arena channel. And if you're interested in giving a talk, it can be just a 5-minute talk about one concept related to the data on Kubernetes ecosystem. And we will help you. We will give you support. We'll be doing rehearsals. That way you'll have a YouTube video showing your skills, increasing your personal brand. So if you're interested in doing that, jump in and we will be able to support you, find a way for you to get involved. Our speaker today is no stranger to the Data on Kubernetes community. No coincidence that we mentioned KubeCon, because in our last KubeCon co-located event, Aleks gave an amazing talk about, also related to Cassandra. But today he's going to be giving us an intro. But before that, I would like an intro to you, Aleks. Welcome to the Data on Kubernetes community again. And how are you today?
Thank you. Well, I'm excited and happy to be here. And it's been a while since we last time met. So glad to see you again. On the KubeCon, we will do ways how do you run Kubernetes for big data and big data on Kubernetes using Cassandra. But if you want to get something from it, you need to understand what's the Kubernetes is and what's the Cassandra is, right? So I will let Bart to take care of you Kubernetes knowledge, and I will take care of your Cassandra knowledge. And that's what we are doing today.
Yep, perfect. That being said, Aleks, you can start jumping in right now with your presentation. Remember, folks, if you have questions, you can ask them in the chat. Also, for folks, just to remember, we have a project where we are going to start putting the rap lyrics. I'm sure you all know very well that we have lots of raps. We're going to be putting the rap lyrics on a database, and that database happens to be Cassandra, right? So there's a lot of relevance in the session we're doing today. We want it to be as practical as possible. If you're interested in working on that project of getting those rap lyrics on the database and then putting that onto Kubernetes, please jump in our Slack and let us know. Get in the beginner channel, beginner arena channel, and we will get you properly situated with our amazing interns and the folks that are already working on that project. Aleks, take it away.
And last point before we go, could you please give me a temporary moderator permissions on YouTube, because I will have to paste some links, and as a non-moderator, I cannot do it.
Here on Zoom, you mean?
No, on YouTube. I can paste them directly.
Or yeah, if you paste them here in Zoom, I'll just put those right over there in the chat.
Yeah, sure, that works for me as well. So let's start. We have only 2 hours, and when I start to speak about Cassandra, well, I love Cassandra, then it may take a couple of days. So let's start right now.
Good, let's do it.
Yeah. So looks like I'm sharing my.
Yep, perfect.
And hide floating meeting controls, and we must be good right now. So, welcome to Intro to Apache Cassandra, decentralized NoSQL database for big data as well, but not only. I'm Aleks Volochnev, developer advocate at DataStax, and my primary work, the purpose of my work, is to help you succeed with Cassandra. Cassandra is extremely powerful tool, but on the scale from bicycle to Boeing, it's way much closer to Boeing than to bicycle. And obviously, if you just jump in on the airplane and trying to push all the buttons, turn all the knobs, you may run into a little bit unhealthy situation. So my work is to let you not fall, but fly. And with that, let's start. So, today we will discuss what is Cassandra, how it works, and when you need it. We will talk about what kind of downsides it has, because you need to understand some potentially dangerous situations and how to handle them. And we will talk about the use cases. Before we proceed, I want to ask you some questions. So the easiest way for you to answer my questions is to go to menti.com and use the code 94257412, or simply scan this QR code and you will be able to answer my questions, because I want to understand the level of the audience today, and it can be a little bit different, so I will know on what I should focus the most and what I can skip more or less. So I want to see you on menti.com. I will send you a link, or actually, Bart, could you please paste this link and the code?
You got it.
Right on the screen, 94257412. And meanwhile, while you are connecting, you will see we will have a little game in the end. I will ask you questions about the content I gave you during today. You will try to answer those give the right answers and do it fast enough. We'll get the prizes from DataStax. So, and today we have quite a lot of attendees, but again, not thousands so far. That means what everyone has a chance to win, and you don't have to be a Cassandra professionals. And our prizes, our swag is, well, quite nice. So menti.com 94257412. And I will start. That's not a competition yet. That's not a quiz, just some setup questions. And I see many people have joined it already. So let us start. First, what's your experience with relational databases? I don't mean like any particular of them, but whatever you know works well. MySQL, PostgreSQL, Oracle, Microsoft, and so on and so forth. And it looks like we have mostly beginners today, and that's completely fine. You know what? I like all of you, because as a students, you are attending these events. It means you want to be better in what you are doing or will be doing. You are curious, and that's what I like in the people the most. So most of you have some understanding of relational databases, and that's great. If you do not have at all, it's also completely fine, because as said, it's introduction. So don't worry too much about that. Next question. What's your experience with NoSQL databases? Normally on this slide, we have like a shift to the left, because people often use relational databases, but not too much NoSQL databases. So that's quite expected. Good, not at all, a little. That works quite well to me. And okay, most of you have answered it already. Let's move on. I don't want those questions to take all day, so let's answer fast. What's your experience with Apache Cassandra or DataStax Enterprise, maybe DataStax Astra? Known. Known, known, known. That exactly means what you are in the right place to be. And okay, we have someone who has already some experience or general understanding. That's also perfectly fine. Let's see if I will be able to surprise you with something. I will try. Have you heard of CAP Theorem? It's also known as Eriks-Brewer Theorem. That's good. Don't worry if you don't. We will cover it briefly today. So most of you haven't heard. We will fix that right now, or at least in a few minutes. So that's good. Now, my final question for today for the setup questions. Normalization, denormalization. Have you heard anything about that? What does that mean to you? No idea. That's fine. I understand these ideas. Denormalization can be useful. Usually people what are not familiar with, yeah, finally I get the answer I was expecting. I quite often hear what denormalization is bad. Is it really bad? Or is it not so bad? Or it can be bad or harmful? We will see today a little bit later. With that, my setup questions are done. I see quite a dispersion, which is great. And we are done with the setup questions, but don't leave main team. We will use it in the end of today's session. And now we go and we start. So what is Cassandra and when do you need that? So it's very important to understand. there are few hundreds of NoSQL databases, and a lot of them are very different to each other. There is not a single, very united family, but like a group of different families. Cassandra is a very interesting thing. It's a NoSQL distributed, decentralized database, and every word in this phrase matters a lot. So NoSQL obviously means not only SQL database. Okay, distributed means what you usually run Cassandra on multiple servers working together. Usually we call Cassandra server a node and a group of nodes working together known as a cluster. And finally, decentralized means what there is no thing like primary node or master node or write node or anything like that, but every node has the same responsibilities, although manages different parts of data, as you will see soon. It's quite the concept, and it's a great thing. You will see soon why. And the last word in this phrase, it's a database. I hope I don't have to explain you what the database is. But if I do, it's just a place you store some data, normally of your clients, of your application. So, as I say, normally you run Cassandra in a distributed way, so you have multiple nodes working together. Group of nodes located together build a data center. And normally with Cassandra, you can have multiple data centers working together. I will show it on the next slides. Traditionally, we call a data center a ring, but well, that's not a ring architecture, but actually every server, every node is able to communicate with every other server. So every server communicates with each one. Normally, they completely, there is no links like from master to slave replica, again, as every server is the same. They communicate using gossiping protocol.
One question, Aleks. Sorry.
We
got a question in from the chat. Ishan, thank you very much.
Mm-hmm.
So NoSQL will mean here that data can be stored in JSON format?
Okay, so data indeed can be stored in a JSON format, but don't rush. You will see soon how it works. In comparison with, for example, MongoDB, the JSON is the primary way to work. With Cassandra, you can use JSON, but there are other ways to work. Let's see. So, then, Cassandra architecture looks quite complex, and indeed, it's not so easy to run Cassandra cluster as, let's say, single MySQL deployment. But do people use that for really? Because it's going to require some skills, let's say, to run a Cassandra cluster. In last report at DataStax Accelerate 2019, well, it was like 2 years ago. It was a great conference, by the way. Netflix reported what Cassandra is for them the primary database, and they have like around 60 or 70,000 of Cassandra nodes with hundreds of clusters, and it's the main source of trust for nearly every data they dispatch. So quite a lot. Can anyone be bigger than Netflix on Cassandra usage? Yes. Meanwhile, at the same DataStax Accelerate, Apple reported one of the primary databases for them to be Cassandra, with over 150,000 Cassandra instances working together, taking care of hundreds petabytes of data. Later on, in 2020, we found out what actually, no, Apple is not the biggest Cassandra user, although one of the biggest Cassandra developers, because we have many Chinese companies like Tencent, WeChat, Alibaba, and so on, also building their business on Cassandra.
Another question, Aleks. Sorry, a couple questions.
Yeah.
One is about how does gossip communication work?
It's a little bit out of scope for today because that's getting deeper. But the general idea is gossip communication means what every node within some time reports its state, its token ranges, I will explain later, and nodes intercommunicating and passing by this information to other nodes. The general idea is cluster to be 100% reliable and available always, 100%. No, not like 99 0.99999, no, 100% of time.
Oh.
And that means what data can be transferred even if the origin source is for any reason unavailable. Then how is data preserved in case of failure of a node? I'm getting there, don't rush, I will explain that. Good. How is number of nodes in one ring decided? Kaiwala asks good question. So how number of nodes on one ring is decided? It's decided by you. So when you add more nodes into the cluster, into the data centers, therefore you will have as much servers as you added them. So it's quite simple. So, and by the way, now those numbers are much higher. So what are the primary features companies picking Cassandra? What are the killer features? So first, Cassandra is distributed and big data ready from the very beginning. So it means what in the beginning of your project, you will be fine with only 3 servers or even with only 1 server, although it's quite rare deployment for Cassandra. You are completely fine and you can go with 1 server, with 3 servers. But if tomorrow, next week, next month, next year, you will need 3,000 servers, it's completely fine. Cassandra scales linearly. When highest possible availability, because of a data distribution and replication and no single point of failure, because it's decentralized or masterless. With the right architecture and right data model, your data stays available literally always. And it's not just fault tolerant, it's disaster tolerant. Then geographical distribution, because of native multi-data center deployments. When you have 1 data center in the United States, 1 in Europe, and 1 in Asia, your system can survive even full data center wipe because data stays available on our data centers. And Cassandra drivers design it a way so they will switch to next available data center. When finally, read and write performance. Obviously, Cassandra is very fast, but not only that. With many of the databases, for example, like Mongo, like relational databases, you can easily scale for write. You add more replica servers or slave servers, and your application may execute a lot of reads. But if you need to scale for writes, then you cannot write to these replica servers. You cannot write to slave servers. You need to write only to master servers, and they aren't so good in scaling, obviously. So Cassandra scales perfectly for write operations as well. And finally, what matters for many of us, what matters a lot for me, Cassandra is vendor independent. Cassandra doesn't belong to any particular commercial company. You know, DataStax stays behind Cassandra, right? But DataStax doesn't manage Cassandra because Cassandra belongs to Apache Software Foundation. Apache Software Foundation is biggest, or probably one of the biggest non-commercial software foundations that manage open source software. And therefore, it's protected from the deep wishes of some of the commercial enterprises, let's say. What are the biggest developers of Cassandra? So far, for the last years at least, Apple was one of the biggest contributors to Apache Cassandra. Netflix, Instagram, of course, DataStax, and many others. So Cassandra is a project baked by many and managed by Apache Software Foundation. Are there any questions? What does scaling linearly mean? Tim van der Keer, I will show that in a moment. In simple terms, what is a big data? Okay, that's a great question. Amit Karnam asks what's a big data? Answer is, there are many scientific answers. I like the simple answers. Big data is the data what doesn't fit a single server. I know it's like in the way, no, not exact, and doesn't sound academic enough, but for me it works. You will see soon. Any more good questions? Big data is a tool used to run SQL queries on huge SQL databases. I wouldn't say so. Big data is not a tool, sorry. Big data means like when you have, when the data of your clients now is not a single megabyte, or terabyte, but like petabytes already, or at least hundreds of terabytes. That's like getting closer to big data. So let's go then. How does Cassandra scale? First, we need to understand how databases normally scale, what are options we have. Normally, when we speak about scaling, we speak of vertical scaling versus horizontal scaling. So what is a vertical scaling? Vertical scaling means you decommission your old smaller machine, bring in a bigger server, more expensive server, put your data on it, and enjoy better performance. So vertical scaling is a replacing of a smaller servers by the bigger servers. Bonus, it's easier to get. Minuses, it's getting extremely expensive very soon. If you watch like on Amazon Web Services, how much top tier database servers cost, there will be very interesting numbers. And still, it's a single point of failure. So it doesn't matter if you have cheaper server or more expensive server, you have one server. There is another kind of a scalability, horizontal scalability. It means what instead of replacing old smaller service with a bigger one, you just add one more server like the one you already have. And it gives us some benefits. First of all, it's cheaper. So it's cheaper to get the same performance level without overpaying. And it removes single point of failure because now you have multiple servers in multiple server racks and multiple availability zones. Then that's also has some downsides. Everything has a price to pay. In this case, it's logistically harder, of course, because now you can manage more things. With Cassandra, Cassandra goes with horizontal scalability, and Cassandra answers to most of the questions what this introduced harder logistics gives. So Cassandra scales horizontally, and that's one of the best Cassandra features. It has nearly zero overhead on adding new nodes. It means what if you have 3 servers Cassandra cluster, if you want to double the performance, you just have to double the number of the servers and you will have doublet performance and doublet disk space. And again and again and again. And of course, there are some not really limitations, but points to understand. If your data model is wrong, it won't work this way. I will tell you why, and like we will speak a lot about data modeling today because it's a primary thing to understand if you want to succeed with Cassandra, and that's my work to make you succeed with Cassandra. So Cassandra scales linearly. That's a question, and I have an exact slide to answer this question. Cassandra scales linearly. What does that mean? It means exactly what I said. Normally, when you bring more servers to your clusters, we have an amount of servers in the cluster, and where we have amount of operations per cluster. And we start to put more nodes, and the performance of the clusters grows as a line. So you see it's a nice straight line. For most of the databases, it would be like that. Like at some point overhead on adding new nodes decreases overall cluster performance. With Cassandra, with array data model, it doesn't happen. Now, that's not my words. This investigation, this research is done by Netflix guys. By the way, if you don't read Netflix tech blog, I do recommend you because Netflix has incredible tech blog. And they did this very nice research with benchmarking Cassandra scalability on AWS. They raised the cluster count, I believe, from 40 servers or something around to almost 300. And what we got was this nice straight line. That's one of the best features which distinct Cassandra in the row of different database management systems. So how it all works? What are the key principles with Cassandra cluster, and what's the main idea? First idea, data is distributed. It means what? Not a single server keeps all the tables you have, but vice versa, your tables are split into parts and spread to multiple servers. For example, here on the right side, we have a simple table, country, city, population. So basically amount of citizens per city, per country. And how it's stored on the cluster. It's stored like that. That means what our table is split into multiple parts and stored on multiple servers. Now, take a look at this. Rows here, we have country as a designated partition key. That means what based on this row, your data will be distributed. So we have all the United States cities on one server. We have all German servers on another server. We have French cities, on another server. And single server can have more than one partitions. So therefore, here we have Australia and India, for example, on a single server, which is completely fine. So why do we do that? Remember my definition a little bit before. Idea is very simple. Big data is the data what doesn't fit to a single server. Netflix has big data. Apple has big data. Many other companies have big data. And you can store these on a single machine only using network attached storages. But the point is, in this case, that cannot be fast. So the first recommendation, if you want your Cassandra to be fast, you need to have not network attached storages, but local disks only. And that's very important. So that's why Cassandra distributes data. Now take a look. For example, the operations done to this table, like we are reading this information or updating this information all the time, we get more and more requests and more people are using our servers. Obviously, pressure grows and at some point, cluster starts to slow down. What I can do in this case, horizontal scaling. Then I introduce more servers to this cluster. Data is being repartitioned and spread it over bigger amount of servers. As a result, every particular server gets lesser payload and lesser workload and may answer faster. So how it will be partitioned? Don't worry, I get there. Partition case is a primary case, I will explain. What about latency between distributed servers? I will explain. NoSQL DML commands are similar to SQL. In this case, yes. Good. Okay, looks like I have slides for every question you asked so far. Let's move on. So how exactly partitioning works? Answer is very simple. Partitioning works this way. Take a look. We have a table. And for every table, we have to define which column or which columns will be a partition key. It can be a single column or multiple. Value of this column will be partitioned by the murmur-free hashing algorithm. And as a result, whatever value it has, in the end, you will have a simple integer number. Now, here we have numbers like 59, 12, 45. Of course, usually it's not 59 or 12, but much bigger integers, like very long ones. But what matters is they're still integers. And we call them tokens. So here we have partition key, and partition key is a value you can read. Australia, Canada, Deutschland, Germany, and so on. But here we have just the numbers. And we have multiple servers in our cluster. Imagine we have cluster of 4 nodes, 4 servers. 1, 2, 3, 4. Every server, every node in the cluster is responsible only for the part of the tokens. It's called a token range. Imagine we have tokens only from 1 and to 100. Normally, it's again not from 1 to 100, but from minus huge big int and to positive huge big int. But we will simplify to explain the idea. So in this case, I have 4 servers, and my overall token diapason, the token range is from 1 to 100. And therefore, it's very easy to calculate. First server will be responsible for tokens from 1 to 25, second from 26 to 50, third from 51 to 75, and so on. And as a result, we can say what Canada, because it has number 12, token number 12, it will go to server A, or first server. When Germany will go with its token 45 to second server, and finally Sydney will go to third server. And so far, fourth server stays redundant, and we don't need it. Now, well, not really not needed. There are some other things to consider, but let's say that's our situation in the moment. Now imagine we start to put more and more data, and we get more and more customers using our system. So at some point, those servers are busy and tired, and we need to have more. When we can add a fifth server, server A, B, C, D, E, server E, we add server E. What happens then? Cassandra cluster is very smart. It takes your job on itself. Idea is very simple. Cluster will automatically recalculate token ranges. And when we will find out what first server is responsible for token ranges 1 to 20, second one will be responsible for token ranges 21 to 40, 41 to 60, and so on. And data will be migrated therefore. But the same happens if we decide what we don't need extra servers anymore, like it's, I don't know, whatever, not right season, people not selling our goods or not using our servers, then we can decommission this server. And exactly the same situation will happen. The cluster will recalculate token ranges for the new amount of servers, and therefore every server will become responsible for larger token ranges. Okay, so let me see the questions. Meanwhile, would increasing the number of nodes increase the performance in Cassandra? Answer is yes. Thank you for the warm words, guys. Will the horizontal scaling be done only after accumulation, or will it happen in a distributed manner? I am not sure I understand the question, sorry. As soon as you add the server, bring server into the cluster will recalculate the ranges, data will be migrated, a new server will become available. How fast it happens? By the way, good question. How fast basically a new server becomes available and fully responsive? Answer is it very depends, because first of all, of the amount of data. The question of data density is very important, and data density literally means how much of the data you have per server. I know companies would prefer high data density, and they store many terabytes per single server. We have seen like up to 12 or 15 terabytes. That's not the recommended strategy. So, I mean, you can do it, it will work, but it will work slow. For cold storage, it's fine. But if you want to have hot storage, which works very fast, you want to have your data density per server smaller. So normally we recommend to go with 2 to 3 terabytes per server. But some companies like Netflix, for example, prefer to have higher startup time. Shorter startup time. So new node starts faster. Obviously, that means what data density has to be decreased, and you have smaller amount of data per server. As a result, it's maybe less efficient from a costs point of view per server, but you can bring on more new servers or decommission some servers faster. So data repartitioning and streaming data within the cluster happens faster. And as a result, you can be more adaptive. So if you can bootstrap new server within 2-3 hours, for example, and you know what, next week or next few days, you will have low count because everyone is on vacation, but it's summer, no one uses your servers. Then you can decommission amount of servers and save money on payments for your, for example, cloud infrastructure. But if you expect Black Friday, Christmas sales, or I don't know, if you are in Netflix and you are releasing a new episode of Game of Thrones or new season, whatever, then obviously you need what pressure will be high, and then you bring more servers, scale out, and you are ready for any pressure what your customers will put on you. So should you have high data density or low data density? Depends on your data strategy. Good. So how to keep data density low? Answer is simple, just bring more nodes and cluster will reshuffle data, so you will have less data per server. Let's go on. We discussed data distribution. That is good. Data distribution helps us to scale out, but it's not enough. Like, you understand what happens if this server goes down? Boom, we have no data about France anymore. And my friends in France, they won't be happy about that. So data is not only distributed, data is replicated. So what does that mean? It means what every piece of data, every row, or better to think partition, is replicated as much time as the replication set for the current key space, for the current cluster, for the current data center. I will show it in bigger details in the future. General idea is what now every server responsible not for the single token range from 1 to 17, let's say, but every server is responsible for 2, or normally we recommend replication factor 3. That means what every server responsible for 3 token ranges. Now let's think about the downside. Obviously, replication factor 3 going to raise your disk space consumption 3 times. Or if you go with replication factor 5, for example, your disk space consumption is going to grow to 5, multiplied by 5. And that's obviously more expensive. But you know what costs more than disk space? Your reputation. So we do recommend to keep replication factor 3. And like, that's a typical deployment. Sometimes you may have more, sometimes, well, we don't recommend to go less, only if you work with on test environment, development environment, very often consists of only one server because you can afford losing data in that. So how it works? Idea is very simple. We remember what every server is responsible for 3 token ranges. And let's say data comes to a server, what's going to dispatch this transaction for us, dispatch this operation for us. And as we see, this data with a token 59 doesn't belong to this server. And this server becomes a query coordinator. So it will coordinate this query. This server is smart. Every Cassandra server is smart. It understands token ranges allocation over the cluster. And as a result, it knows what those 3 servers are really replica servers for this partition. Therefore, this server will dispatch asynchronously 3 write requests to those servers, and they all will get the data in the end. Now, what happens if one of the servers is on fire, not available, power outage, network outage, whatever outage? Idea is very simple. This query coordinator will store so-called hinted handoff. Hinted handoff is just a spatial data. What will be dispatched to the failed server as soon as it recovers. When failed server recovers, it reports like, okay, guys, I'm back online. Sorry for me being late. Did I miss anything? And then all of the query coordinators, so basically every servers what got queries for the token ranges this server is responsible, they will dispatch hinted handoffs to it, and it will recover. And it is completely automated. So if you don't watch your logs, if you don't watch your monitoring, you won't even be notified, and cluster will be self-healed. For shorter outages, it's completely automated recovery. Now, what happens if your server was out not for 15 minutes, not for 1 hour, but let's say for 1 full day? In the highly active cluster where some operations happening all the time, recovery with hinted handoffs may be too expensive. I mean, like from the point of view, imagine this data is being accessed and changed all the day, every second, and then server recovers to say, okay, I'm here, and gets like all the terabytes of new data thrown to him. Obviously, that will be a bad idea. So those hinted handoffs have a default setting depending on the version. It may be usually like 3 to 4 hours. If your server recovers within those graceful period time, 3 to 4 hours, you can change the setting, of course, but don't make it too big. It may bring more problems when it will solve. So if graceful period time is over, hinted handoffs will be decommissioned, and it's easier to you in many scenarios will be to decommission this failed server at all and bring it back as a new server, because it will use another mechanisms to bring data in, which may be better for your cluster overall. So, are there any good questions, Bart? I see you have some fun there.
Any more Game of Thrones? Let's see. In terms of other stuff, since we spoke about our RF and data replication, do the nodes use a slower driver for replication, or do they have uniform data storage? Like solid state storage for all data.
So, of course, it's recommended to use SSD disks for everything, for sure. What may help to raise performance a little bit is to have 2 different SSD disks per server. I don't have real measurements, but the point is there are 2 kinds of write operations on disk happen. Normal persistence of the data and write ahead log known as a commit log. And to keep them isolated from each other, it may have more sense to have 2 disks, at least when those magnetic disks, like those spinning. With SSD, I have to check, but normally, yes, we recommend to use just the uniform data storage SSD, but local one. Good. Does the RF increases with the increased number of nodes? Answer is no. RF is declared by the administrator, and just bringing more servers into data center, in the cluster, won't affect replication factor. You set replication factor manually. Moreover, you can have different replication factors for different sets of data, because sometimes you have like extremely important data, some financial statements, and you don't want to have any risks of loss. And sometimes you work with a secondary data, which you don't want to consume all of the disk space, so you may decrease replication factor for this piece of data, so it's configurable. So we are getting to CAP theorem, and this one is a very important one. Let's take a look on what sorry, Bart? Okay, so CAP theorem, or consistency, availability, and partition tolerance theorem. Cassandra is a distributed system, and this CAP theorem works not only for Cassandra, but it works for literally every distributed system. If you work on something like distributed system, like whatever microservices, a server, service-oriented architecture, and so on and so forth. If you work on the distributed system, this system also applies, this theorem also applies to your system as well. What it states, idea is, in a distributed environment, so more than one server, in case of an outage, in case of a failure, only 2 qualities out of 3 can be reached, and you in the best case scenario. And you can decide which one you want to have. So you can be here, here, or here, but you cannot be here. You cannot be in the center, and you can decide where you want to be. Now, there is very often misunderstanding what Cassandra is available and partition tolerance. If you ask, is Cassandra CP or AP, like 80% of Cassandra users, maybe more, will say Cassandra is AP. And that's a mistake, and you will soon see why. So, but first of all, let's discuss those qualities. So what exactly does that mean? Consistency, availability, and partition tolerance. Let's start with the availability because it's the easiest quality to explain. Availability means simply you get the answer. You ask your database, you get the answer. You ask some server, you cannot reach the server, your driver switch to next available server, you get an answer from the next available server. It goes seamlessly for your application. It's called availability, and Cassandra is highly available indeed. Then, what means consistency? Consistency means what you always get most up-to-date data. It means because we store data duplicated to multiple servers, in case one of the servers didn't get the update, didn't get for any reason commit log, wasn't repaired to the right state, you in theory can get outdated information. And user email has changed, you ask for it, but you ask the wrong node what stores outdated information, and you will get outdated information. That's obviously bad. So consistency in this case means what you always get actual information. And finally, partition tolerance. Partition tolerance is the most misunderstood concept here. Partition tolerance means ability of a distributed system to survive network split, network partitioning between servers within these cluster or between servers of these system. So if you have, for example, data center in Asia, data center in Europe, and data center in the United States, and European and Asian data centers can communicate and they can work together, but United States servers is operational but unreachable because of some network outage between continents, it's called network partitioning or network split. And it's a very bad situation, actually. In some cases, it can be much worse than just complete loss of the United States data center, because loss of a data center normally means it will recover in some time, but network partitioning in theory may lead what some of your clients work only with segment 2, so Europe to Asia, and some of your clients work only with segment 1, so United States data is not distributed because of them, and in the end, you may end up with two completely different versions of the data. And these call it split brain state, split brain state. Split brain state is a huge problem, like very, very huge problem, because there is no simple way to recover from this state. There is no technical means to recover from split brain, but only like really a lot of human work, let's say. And that's a big problem. So then take a look. We have to pick two qualities out of 3 for our database management system. What can we decide on that? First of all, there is no way we can afford network partitioning. There is no way we can afford split brain, because for the company like Facebook, recovery from split brain will take months, maybe on downtime. So partition tolerance, we cannot afford in no way. It means what basically we have to decide between availability and partition tolerance, and consistency and partition tolerance. What do we want to have the most? There are many different databases with different approaches. Some of the databases are CP, consistent and partition tolerance. Some of the systems are AP, available and partition tolerance, but eventually consistent. Where is Cassandra? Cassandra is configurably consistent. So please don't call Cassandra CP, it's a mistake. Cassandra AP. Neither. It's neither AP or CP, but Cassandra is configurably consistent. In any moment of the time, for each and every particular query you execute, you can set desired consistency level you require to have. What is a consistency level? Consistency level is defines amount of the servers, of the replica servers, you will await for confirmation from them before you return confirmation to a client who executed a query, who executed a statement. Take a look, like the most widely used consistency levels are 1 to 3, quorum, and all. What does that mean? So take a look. When I write data and I have replication factor 3, then there is a client, so normally your application, and that's my cluster of 6 servers. Client writes data to some server. This server is not replica server, so it will dispatch this data. Let's say if you write something to responsible servers. And we have 1, 2, 3 replica servers. Data will be dispatched to all of them simultaneously. But how many confirmations we will wait till we return information to a client? With consistency level 1, we will wait for 1 and only 1 confirmation. Again, don't get to the trap. Data will be dispatched to all servers. It's not like we only dispatch data to a single server. No, we dispatch data to always all replica servers. But how many confirmations we will expect? Only 1. With consistency level quorum, we will wait for confirmation from majority of servers we have in the cluster for this replication factor. For example, majority of the servers for replication factor 3 means 2. So majority quorum literally means like a little bit more than a half. In this case, if replication factor is 3, majority is 2. If replication factor is 5, majority is 3. So half plus 1. Or round up to whole number. Then, finally, with consistency level all, we will wait for all of the confirmations. Now, let's get back. With consistency levels 1, 2, 3, we wait for a dedicated amount of servers to confirm what data was written. Or a data we select from cluster is matching. This data is the same if we are not writing but reading data. Quorum means majority. All means all replicas. And for multi-data center deployments, we have some more options. For multi-data center deployments, we have local one and local quorum. What does that mean, local? Imagine you have your data centers as set in Europe, United States, and Asia. What happens when we use local? Local means data center closest to your application server. So usually you run your database on one server and your application on another server.
Alex, we got a question.
Sure.
So for a very important query, you would configure with a higher consistency level?
Right, and I will explain that in a moment.
Okay, good.
Yeah. Thank you. So yeah, this is a good one. So obviously, you don't want your application server in United States to work with your database server in Australia. It will bring obvious latencies you want to avoid. And then you specify for your application server in the United States what United States database server or a database data center is local for it. Therefore, using consistency level local one or local quorum will mean what application server in the US will always try to work by default with a data center in United States, not in Asia, not in Europe. So it's obviously will be faster. And local one means the same as one, but within local data center. And local quorum means what we will wait for the quorum, but only in the data center closest to us. Quite opposite, each quorum will mean what we will wait for quorum in each and every data center what stores your data. And as a result, we will wait for the quorum here, there, and over there. And although it's like the most reliable way to work, obviously, it still will be much lower. So normally we use local quorum approach, not each quorum and not just a quorum. So now take a look, consistency level all. Consistency level all means what we will wait for all answers. Is it good or bad? There is no simple answer, because for some scenarios it will be good, for some scenarios it will be bad. But you know what? We have a problem here. CEP theorem is still here, and there is no way to cheat it. So when you bring consistency level all, what will happen? I have to move this slide. Oops, too much. Give me my CEP slide, right? So with consistency level less than all, we are in availability and partition tolerant place. But if you bring consistency level to all, that brings us eventually to consistency and partition tolerance side. And boom, our Cassandra is CP. What happens then? As soon as one single replica server is not available, Cassandra cannot reach desired consistency level. And boom, you have an exception. Sorry, desired consistency level cannot be reached. Come again later, sorry. And that's because we prefer consistency over availability. And now with consistency level all, we cannot tolerate even a single server loss. Now you will tell me, but I work with very important data. I don't want to dispatch inconsistent data. What do I do to give answers to my clients, give the very right answers? I still want to be available. I want to afford losing of the data. I want to afford losing of a server, but I have to be consistent. How do we solve that? There is a trick, and I will teach you. There is a thing called immediate consistency. Immediate consistency is quite a simple idea. Take a look. My replication factor is 3. And I write with consistency level quorum. Quorum for RF3 means 2. And then just mathematics. If I write with consistency level 2, so quorum for 3, and if I read with consistency level quorum, so 2, I always get most up-to-date answer, and there is no mathematical, that's not a single chance I will get outdated information. Why? Take a look. Write with consistency level 2 out of 3 quorum. I wait for 2 confirmations. This server also will get the data, but it didn't confirm the data yet. So basically, at the moment of the write, I don't know if this server got the data, or maybe it's down on fire, stolen by aliens or whatever. Then, but I do know what data is at least on 2 servers of 3. Then I'm trying to read this data. And when I try to read this data, I request data from all 3 servers, obviously. And as soon as 2 servers return data, if this data is matching, so 2 servers have the same answer, I immediately dispatch answer to the client. And as a result, after a write quorum, if there are only two options, or I reach 2 up-to-date servers, I immediately get my data. Or there can be a bad scenario when 2 servers answer fast, so first 2 servers to answer. One of them has most up-to-date data, and one is inconsistent. For whatever reason, it didn't get the update. What happens then? Query coordinator sees what we have a problem. Query coordinator sees what servers are returning different values. As a result, what it will do? Query coordinator will dispatch the most up-to-date data, so consistent data, to the client, and initiate an internal repair on a failed read to recover failed node to bring it back into the consistent state. Only 2 options. In first way, in the good scenario, you immediately get consistent data. And in another way, you again immediately get consistent data, but also Cassandra will execute a repair in the background. So when you write with quorum and read with quorum, you have immediate consistency and you always get the most up-to-date data. In general, the rule is very simple. If consistency level of write plus consistency level of read is higher than replication factor, you have immediate consistency. So that means you can write with a consistency level all. After that, you can read with consistency level 1. 3 plus 1 higher than 3. So 4 is more than 3. You have immediate consistency. But in this case, your write has to be executed on consistency level all, which is bad, as we discussed. Quite opposite, you can write with consistency level 1, and then you can read with consistency level all. That also will be immediate consistency, but again, you use all, which is bad for high availability. So that's the immediate consistency, and that's how it works. Now, I see incredible question by Chris, looking for resources on Cassandra for operators. Any suggestions? Oh, yes, I have two. First, we have academy.datastax.com. Academy.datastax.com is a free educational resource for Cassandra team, Cassandra people, and we have a special Cassandra operations path. So you can learn everything you need to know to manage Cassandra cluster. But not only that, that's not enough to just know. Okay, just know is great, but if you can confirm that to your employer or someone who may consider hiring you, then it's always better. Because you all attended this session, in the end, we will dispatch a special voucher form. So you get a voucher to pass certification exam on Cassandra for free. And you can become a certified Apache Cassandra developer or Apache Cassandra operator absolutely for free, because Academy is free and exam, okay, exam have costs, but you will get the voucher, and that's great. Now, don't make a mistake. This course is not enough to pass the exam. Don't even try. You have to take courses at the Academy, but they are free. They only require your time. So, there is a question from Abhijit Ganesh. Wouldn't be a one-way roadblock if there is a CL1 write and CL0 read if the CL1 server fails? So take a look. Anyway, data is spread over multiple servers. So data is delivered to every of the replica servers. Consistency level is only about how many of confirmations we await before we return data to a client. So, finally, data distributed everywhere, and you can have your data distributed geographically, and that's very important of two reasons. First, keep your data close to your clients. You know Uber? I believe some of you, maybe most of you, are using Uber, of course. And if you go to an airport with Uber in Europe, and let's say you go to Frankfurt airport, for example, why not? Nice airport, especially Terminal 1. And you fly to, I don't know, whatever, Orlando. You will work, and again, take Uber to get to your place, to get to your hotel there. You will work with the same Cassandra cluster or DataStax enterprise cluster, but two different data centers. And answers will be fast. So that's incredible. Keep your data close to your customers. But not only that, as we discussed before, Cassandra is disaster tolerant. What was the name of a hurricane which nearly destroyed New Orleans? Katrina, right? Yes, it was Katrina, I believe. So,
correct. That's correct.
Yep. And Katrina destroyed data center of one of our clients. What was the downtime of their application? 0. Because of this geographic distribution of data. So Cassandra is disaster tolerant, not only fault tolerant. But not only that, as Cassandra doesn't belong to any cloud provider, but to Apache Software Foundation, non-commercial, non-profit organization, Cassandra is platform agnostic, and you can have a single cluster, but running simultaneously on Microsoft Azure, Google Compute Cloud, Amazon Web Services, your own data center on premise simultaneously. And basically, that's incredible, because if tomorrow AWS introduces twice costs of data storage for your Cassandra cluster, you basically migrate to another, I don't know, to one of the Ali cloud, one of a Chinese cloud, or whatever cloud you prefer to use. And that's again completely automated. You bring on a new data center on another cloud, data is migrated by Cassandra cluster, you take down the previous cluster, you are good, and it all can happen in a couple of days, depending on amount of data you have. It's quite of a way to leverage your communication with data, with cloud providers, if you believe what their prices are not fair for your company.
We got another question.
Sure.
What does Cassandra do to handle deleted and updated rows? For instance, in Postgres, there is a background process which cleans and reclaims space from deleted and updated rows.
So that's a good question. Sadly, right path, which I have slides, but we won't have time to cover them today. With Cassandra, that's quite an interesting approach. There are two steps to consider. First, Cassandra uses commit log, write ahead log. So every data is persisted immediately in the moment when it reaches the server. But it's a fast storage, but not the storage to work with for real. It's on the storage only before data is persisted already in the right place. And this right place to store data is called SS tables, sorted string tables. Sorted string tables are immutable. And now there is a fun fact. In Cassandra, every operation like insert, update, or delete is technically exactly the same operation. So there is no principal difference between insert, update, and delete. Because SS tables are immutable, we cannot delete a part of this table. We just write the data in the form of a so-called tombstone. Okay, this row has been deleted, but it will be like one extra row with this tombstone value in the end. That's easier to show with the slides, of course. Thank you for a good question, Joe. But for this one, you better go to our academy.datastax.com and pass a full course on Cassandra, not this. We have only 2 hours today, and we still have to cover more of them. I will move on. Now, there is a question. What are the backdraws, I believe, of Cassandra in the current date, if any? I will show you. There are some issues. So, but we will get to issues and downsides a little bit later. First, speak about normalization in denormalization. What is it? Normalization and denormalization. You guys today are very cool because you don't claim denormalization as an evil. Because normally when I do this part of the workshop, or when we speak about normalization and denormalization, people say what they are taught in schools, universities, what normalization is great and denormalization is evil. And like what was that, only Sit brings everything to absolute. I'm not sure of the quote, but the idea is there is no light side and dark side. It's not like normalization is good and denormalization is bad. No, denormalization can be good as long as you control it. As long as you control denormalization, it's good. When denormalization controls you, it's bad. So let's talk about what of that? What's the denormalization and normalization? Database normalization is a process of structuring data in a relational database in accordance of a series of so-called normal forms in order to reduce data redundancy and improve integrity. First was proposed by Edgar Cott in, I believe, 1960s or something like that. I don't remember exact date. What the idea of a normalization? The idea is to reduce redundancy. And for example, if you run employees to departments, employees management system, you have your employees table, user, first name, last name, ID, first name, last name, ID, first name, last name. you have department table with department ID and department. Department 1 will be engineering, department 2 will be math, and so on. So then you want to show list of your employees with the department on the right side for each of them. Then you can execute join. When some of you are not familiar with SQL, but simply explaining, we have two different tables. But when we try to get data from them, we may use a special construct called join, which will combine data from multiple tables. And as a result, we will know what Edgar Code works in engineering department, Raymond Boyce works in math department, and so on and so forth. What are the benefits of this approach? Obvious. It's a simple write and data integrity. Because of this simple write, if I create a new employee or if I change anything, I will have to execute only one insert or only one update. If I rename a department from engineering to, I don't know, whatever, black magic, because engineering very often looks like black magic, I will execute only one update. Update, department, set department black magic, where department equals engineering. Only one update. So simple write, data integrity. Using foreign keys, using these relations between tables, I can keep some checks, I can keep some cascade operations. So that's quite cool. What are the downside of this approach? Because every approach has its downsides. There is no silver bullet. So negative sides, slow read. Slow read, it means if we have to execute operation with multiple joins, and that's a very often a thing, then every next join will be slower and slower and slower. Overall duration of a query will be slower, and our customers are unhappy. I don't know about you, but I am always unhappy with when a service online works slow. And next disadvantage, complex queries. I know some of you familiar with relational databases, and I believe already familiar with join. What do you think? How many of join operations are allowed in a single select statement for MySQL? How many select, join, how many joins you can have in a single select statement? Please answer on the YouTube chat. And meanwhile, I will answer, this presentation will this presentation be available? That's a question not to me, but to Bart. But normally, as far as I know, data on Kubernetes persists all the streams here.
Yeah. They're very persistent.
Yeah, okay.
Yeah, if you're referring to the slides, Aleks, I don't know if you share your slides or not, but the video will be directly on our YouTube channel immediately afterwards.
Okay, and I can bring you slides as well.
Okay, cool.
Yep. Question from Abhijit: Cassandra resembles the concept of blockchain a lot, doesn't it? Well, I wouldn't say so. I believe it's a little bit different concept, I believe. Okay, I'm expecting 10 plus, 1,000. Okay, so answer is at least when I first met this limitation, so it was around 8 years ago, maximum amount of joins in a single select statement in MySQL was 61. 61, there is a limit, or at least it was in MySQL version 5, I believe. Maybe now it's so far, I have to check. But the general idea is there is a limitation, but that's not about is MySQL has any limits or not. Well, okay, it is. My question is, can you imagine maintaining a query with 61 join in it? There is a word complex queries, and that's there for a reason. Maintaining of a normalized table, it's very hard to maintain them. And no, sorry, Abhijit, I cannot confirm. Maybe in the newer versions of MySQL, there are no limits, which I doubt, but at least in the previous versions, they definitely were limits. I can confirm it. With bloody tears in my eyes, I reached these limitation ones. So let's proceed to denormalization. What is a denormalization? Denormalization is a strategy used on a database to increase performance. First of all, read performance. In computing, denormalization is the process of trying to improve read performance of a database at the expense of losing some write performance by adding redundant copies of data. Now, imagine we have this department data already into the table of employees, and we have Edgar Code Engineering, Redmond Boyce Math, Sage Lahya Math, Juniper Jones Botany, and so on and so forth. As a result, we don't have to execute any joins, and we immediately get all the data within one query. So what are the advantages of this approach? I'm very curious about where is my, okay, my mouse is here. Quick reads. Quick reads means basically what we have our data delivered immediately with no joins. And the second benefit, queries are much simple. And downsides. Obviously, we need to have multiple writes now. You see, it's not shown here, but we still have table departments because we still have to store data about the departments. And if we have to rename or update department, now we have to execute multiple operations, which is quite sad. And manual integrity. In case of, because Cassandra is a NoSQL database, we have no joins. There are no relations, there are no foreign keys. We cannot use joins. And as a result, we cannot use database features to maintain data integrity, and we have to execute it manually at the application layer. Is that a problem? Well, yes. I mean, as an application developer, I have, using Cassandra, more work to do when I work with relational databases. But on the bright side, as a Cassandra-enabled developer, I usually work with companies big enough to pay decent salaries. Companies like Apple just vacuuming job market, and we lost some people of my own team in DataStax because basically it's quite hard to beat Apple from the salaries point of view. So I have more work to do, but I'm getting well paid for it. So I can survive the issue of manual integrity or integrity developed on the application side. Good. So that's the story of normalization and denormalization. Now, what are the key difference to understand? In the second case, we have to do more work when writing data. When I have my data model distributed, denormalized, I have to execute multiple writes, more work on the write time. Using normalization, I have simple writes, but I have to do more work on read time. The decision kind of looks simple. Depending on what you have more in your application, you can rely more on normalization or denormalization if you have more reads. But actually, it's even simpler than that. Take a look. When I have multiple joins, they cannot be executed simultaneously. They can be executed only consecutively. So I have join on a table, join on the next table, join on the next table. I cannot just execute that in parallel. I have to execute first join first, then I can execute second join, then I can execute third join. Let's compare with multiple writes. Multiple writes to different tables they can be executed in parallel because of a very simple reason. Cassandra is very good on the write performance. So therefore, despite it looks just quicker reads or quicker writes, idea is I can parallel writes, I can execute them in parallel, but I cannot parallel joins. So here the normalization has some more benefits when we just expect. Yeah, and Joao says, keep your enemies closer to you. This is the normalization. Yeah, it's something like that. Good. So the key feature for us first is a key space. What is a key space? Key space is like a database or like a schema in relational databases. It keeps tables. So first we create a key space. When we create tables within key space. When we create key space, we use CQL, Cassandra Query Language. What is a CQL? It's a bless and curse of Cassandra. It's designed to be as simple, as similar to SQL as possible. And it's great and very bad at the same time. Why it's great? Because it's easy to learn. If you have used SQL before, it will be very easy for you to learn CQL, Cassandra Query Language. And that's great. But what's wrong with that? People who has experience with relational databases, who know SQL, when they see CQL and they think, oh, CQL is like almost like SQL. I can use it already. I'm ready to use Cassandra. And that, my friends, leads to very, very, very big problems. Then people who think like that, they take Cassandra as MySQL without joins, and then they try to use Cassandra as MySQL without joins. And you know what? Cassandra is not MySQL without joins. It's very different. So they do very wrong data model. And if your data model is wrong, it will fail inevitably when you will need to store more and more and more data or dispatch it faster and faster and faster. So let's go deeper to the data model. Key spaces. First, we create key spaces. Creation of a key space is quite simple. First, we have to create key space with some name. And there are multiple different options, but the first option we have to consider is a main option, like we must always specify explicitly in the create statement, is the replication strategy. So replication class can be network topology strategy or simple strategy. Before we were more, now we use only two. So simple strategy is, well, very simple as it states. You can use simple strategy and it's good for your laptop and it's bad for anything else. If we speak about staging environment, production environment, you always need to use network topology strategy. What is a network topology strategy? You can guess from the name, it's a strategy aware of a network topology. What's the point? Imagine we have a data center, our own on-premise hardware. So data center, server racks inside, and inside server racks, we have servers, and we run Cassandra on them. Imagine we have 3 server racks, A, B, and C, and we have 9 servers. So they will be like server rack A, 1, 2, 3, server rack B, 4, 5, 6, server rack C, 7, 8, 9. How simple strategy will allocate token ranges over servers blindly. Simple strategy just tries to put it as simple as that, and that's its job. But you are smart and curious and want to be good engineer, so you will know what you have to use network topology strategy. Network topology strategy, what is it responsible for? It will try to keep replica servers as far away from each other as possible within single data center. So what do we want to have from our replica servers for a partition, for a token range? Do we want them to be stored on a single server rack? Like your replica servers will be 1, 2, 3 for this piece of data. No, we don't want it. Why? Servers located within the same server rack, they tend to fail together for a very simple reason. If they're located together, you may have some more problems because server rack tend to fail together. So just of a power outage, network outage, and so on. So network topology strategy will try to put replicas to different racks. One replica will go to server rack A, another one to server rack B, and so on. So here idea is simple. For your laptop, for a test or for development environment, put simple. For production, obviously network topology strategy. When next point we need to understand is the replication factor. So we specify replication factor by data center, and it can be different. So here we have specified 2 data centers, US West 1, replication factor 3, and Europe Central 1, replication factor 5. It means what? In United States 1, I will have replication factor 3 for all tables in this key space. I can have more key spaces, and for tables in there, I can give different replication factor. And for Europe Central 1, I will have replication factor 5 for tables within key space users. Now there is a question. How many data centers I have in this key space, I have in this cluster? We won't wait for YouTube chat to get answer. I will answer right now, but just now imagine number in your head. How many data centers do I have in this cluster? Good. So the answer is, we don't know. From the this declaration, if we expect it right, answer looks like 2, but really that doesn't mean anything. I can have 10 data centers within this cluster. I just, for this piece of data, for these tables, I'm going to use only those 2 data centers, and other 8 I won't use for these, at least for now. I can later change it, of course. That's, by the way, use it for the situations when you want data of, for example, your German clients to be stored only in Germany, so GDPR. Yeah, so we do not know amount of data centers in this case. We expect 2 or more, if this statement is correct after all. So then next thing, we have to create tables. And how do we create a table in SQL? Answer is very simple, with a create table statement. So create table statement looks very similar like in a standard query language. For a reason, it's designed to be this way, but there are some differences. Well, first, creating table, first we have to specify the key space and the table name. So key space will be killer video in this case, and table will be users by city. Then we have to define some columns, so city, last name, first name, address, and email, and they all will have type text in this case. Well, of course, believe me, we have more types than just text. And then finally, we have to define primary key, primary key consists of partition key and clustering column. I believe some of you are already typing questions, what is a partition key and what is a clustering column? Don't rush, I will explain it in a moment. So, most important things in a table is the primary key. Primary key consists of 2 parts, partition key and clustering column. In this case, we have primary key of city, last name, first name, and email. That is, what's that? Primary key have 2 responsibilities. First, it must ensure uniqueness. And second thing, may define sorting. And let's take a look. What's the good example here? Primary key, city, last name, first name, email. And then bad example, primary key, city, last name, first name. What's wrong here? Why this second example is bad and first example is good? Answer is very simple. As the primary key defines uniqueness and we don't include email into the primary key, what that means? I believe in New York, you have like around 24 of John Smiths. And obviously, every next John Smith will be a very bad surprise for the previous John Smith, because every new John Smith in this table will overwrite data of a previous John Smith if we don't prevent that. And there is a point in the chat, this seems similar to MySQL, apart from mentioning the key space. Yes, that indeed looks similar to MySQL, and that is a trap. It looks like MySQL, but it's not. So that's what I was saying before, be careful, don't try to use it like MySQL. It may lead to very bad problems. Okay then, when meanwhile, if you have some universally unique identifier, you can use it as a primary key. So if you have table of just users and you have unique identifiers there, then your primary key may consist only of one single key, and it's completely fine. It's completely acceptable. It will lead to situation, so you will have as much partitions, as much users you have. Is that bad? No, it's not bad, because in Cassandra, you may have as much partitions as you want. So therefore, it's completely fine to have a single partition per row. It's fine. Okay, so what is a partition key? We discussed it already. Partition key is a key what identifies a partition, and it one and only job is to partition rows. Partition key is extremely important because it defines data distribution over a cluster. And in this example, we have, as discussed already, primary key of user ID. In this case, user ID will be partition key, and it's completely fine. But then, primary key, video ID, and comment ID. Is that fine? Take a look. We have a table of videos, like YouTube videos have comments. And we need to make design for comments of this video, of this table. Remember, all the rows with the same partition keys will be stored together. And of course, we can execute as less operations as possible. Well, then, if I normally open a video on YouTube, I want to see comments for this video, and I don't want to execute a dozen of select statements to retrieve all the comments, or dozens of network operations to retrieve those comments. Then for these comments for my video, I use a video ID as a partition key. And as a result, they will be stored together, retrieve it within a single select statement, and I will get them immediately. And that's again a nice partitioning. Regarding this bad example, I have a special slide to explain why it's bad. And finally, clustering columns. So second part of a primary key. In this case, that's last name, first name, email. What are they and how do they work? Idea is very simple. First, they use it to ensure uniqueness. And second, sorting order within the partition. Clustering columns are optional. We can skip them completely. So first example, we already discussed it. City, last name, first name will work as long as you have only one John Smith per city. Then city, last name, first name, email will work because that's unique, or at least unique enough for our scenario. But then we have this example, or video ID and comment ID. Will it be unique? Yes, because both video ID and comment ID are universally unique. So that's fine from uniqueness point of view. But is it good enough for our YouTube system? Not really, because we want to show all comments, but most latest first. And as a result, if we just store them by video ID, comment ID, they won't be sorted by time. So here we go with video ID as a partition key, created as a clustering column for sorting purposes, and then comment ID for uniqueness. We cannot use created for uniqueness purposes because created like multiple comments may be created at the exactly same moment of the time. So we have video created at comment ID. In this case, clustering column will sort them and we will be sorted by them within the partitions. Now, we have not so much time left, and I still want to play a game with you and dispatch some prizes then. I adore that. So those slides are the most important slides of this presentation. Mostly probably those slides most important slides of each and every presentation you will see this year. That's why we have got the Slide of the Year award. Well, I created those slides and I assigned at least award to them. It sounds like a little bit maybe too much, but I do believe they are deadly important. If you ever will use Cassandra, if you know those rules, if you use these rules and follow them, you will be good. If you don't know them, if you don't follow them, you will run into very heavy and serious troubles. So there are only 3 rules you need to know. First, store together what you retrieve together. In this case, we discussed it already. We partition comments of a video by video ID. When I open this video, I can retrieve all of the comments within one single select statement, and I'm good. Well, then primary key, comment ID created at. We try to store comments. We will have as much partitions as comments we have. In this case, if we are going to read all the comments to the video, we have to read as much partitions as comments we have to the videos, which is obviously stupid. So,
quick question about partition.
Yeah.
Someone said, I didn't get the point to create, for instance, a partition for each user if I just have 1 row per user, like primary key on user ID.
So you see, what's the point? Joao, thank you for a question. It helps me to help you get it to the full. The story is, then you access data in your relational database. How do you think? First, you have database, then you have table, then you have row. And retrieving data, you have to specify database or schema or whatever key space in the case of Cassandra. Then you have to specify table, then you have to specify the key or something what will uniquely identify the row you are going to get. And you think in this simple approach. Database, table, row. Sounds good, doesn't work in Cassandra. Because in Cassandra, base unit of access is not a row, but a partition. And if you forget that, it will strike back hard. So in Cassandra, you think key space, table, partition, row. Row is always packed into the partition. There cannot be row without a partition. And there is always a partition. Partition has, nearly 0 expenses per se. So don't be afraid to have 1 partition per row. It's completely fine. I hope I will explain that. So let's move on. Avoid big partitions. What does that mean? Take a look. Why do we do partitioning at all? Because we are ready to handle any amounts of data. Today you have, I don't know, few kilobytes, it's fine. Tomorrow you have gigabytes, it's fine. Next day you have terabytes, petabytes, you still fine. Just throw more servers into your cluster, right? So, but if your partitions are getting too big, then obviously you will run into trouble. And we again run into the problem, too much data on a single server because partitions store it together as a file or part of a file on a server. And then it's getting too big, it's getting too dangerous. In this case, good example, we partition comments of a video by video ID. You may say like, okay, so some videos have huge amount of comments, and you are right. But comment by itself is just like few bytes of data because normally it's ID video, ID comment, ID author name, timestamp, and text of a comment. So it's a short text thing, so it has no like too much weight. But if you partition your data, for example, for your customers by country, there will be some countries like Monaco, and there will be some countries like India or China, and you will have like very unbalanced story. So maybe you need to think of having as even partitions as possible. What are the limitations? Technically, there is one and only one hard limit. One partition may have up to 2 billion cells. Cell basically is a row calculated by, multiplied by columns. Calculate amount of rows by amount of columns, you will have amount of cells in your partition. That's only hard limit, so quite a lot. But recommendations are, in general, we recommend to stick to more or less 100,000 rows in a partition, more or less 100,000 megabytes in a partition. Those are not hard limits, so in some reasonable way, you can exceed them. As said, I've seen like a partition of 1 and 1.2, I believe, terabytes. That's a disaster. Don't do like that. Your database cannot be fast with that. Try to keep it reasonably small. It will really work much better. Now, take a look. Let's solve a problem. Imagine we work in a huge IoT. Imagine we work in a huge telecommunication company. Huge global hardware all over the world. Very huge IoT infrastructure. Billions of different sensors reporting their state every 10 seconds or every few seconds. Every sensor report is simple. Every sensor reports its UUID, timestamp, and value. Like sensor ID 1542, timestamp, so when something happened, and value is a float. What is the value in this case? It can be temperatures, it can be network output, I don't know, humidity, whatever. Door open, door closed. Also a report of a sensor in Internet of Things. And originally, to store this data, we designed our table like that. Partition key to be sensor ID. So we will follow the rule 1, store together what you retrieve together. We partition everything per sensor. And as a result, we have everything grouped by sensor. If I want to read the data from one single sensor, I can get it in one single query. Okay, and to keep the data unique, because sensor ID will be the same in every next report, obviously from the same sensor, we added reported at as a clustering column to keep our data sorted by time and unique meanwhile per sensor per record. Does this design works? Yes, it is. Is it a good design? Not so good. Now, tell me please on YouTube chat, what will happen and when it will happen and why this design is bad.
Getting answers for that. Could you also answer a quick question? Why are those recommendations there, especially the 100 megabyte one?
So recommendations there for a very simple reason. You need to keep your partitions of a reasonable size. So that's not like if you exceed 100 megabytes per partition, your company should fire you. Not like that. But people often ask us like, what should be desired partition size? And it should be of a reasonable size. So like 100 megabytes, it's fine. Good. Are there any more questions?
No, I think for right now, I think we're pretty good.
Okay. So we are almost done with the slides. I want to play a game.
Yes.
And I only wait for answers on the YouTube chat, like why this design is bad, and when I will run into troubles, and why. Yeah. I like those questions. They make you think. We will have a massive inflow of data if we keep adding data to the storage every 10 seconds. It goes against the idea if we enforce point 2. Nope. Nope. Point 1. Yes. So I will give you 30 more seconds, store together what you retrieve together. I will wait for a second more. I'm out of water. It will be a huge partition, and that's the right answer. And actually, Answer is right on the screen. Ladies and gentlemen, avoid big and constantly growing partitions. So, massive inflow of data. Is it a problem? No. You can afford as much of the data inflow as you want, as long as you have enough servers, because Cassandra scales. Many unique partitions. It's not a problem because you may have as much partitions as you want. That's not a problem. But the answer is, then you have data partitioned only by sensor, and data arrives again and again and again and again every 10 seconds. Then over months, your partitions will be too big, all of them together. So just again, it's two big partitions. That's what this design, that's the rule this design breaks. It's not the first one, it's completely fine from this point of view. You store together what you retrieve together. You want to see data of a single sensor. It's completely fine. But again, partitions are growing too big. That's a problem of this partition. Now, there are two solutions. Solution number one, you can allocate so-called TTL, time to live. In Cassandra, every row, or actually a part of a row, may have time to live, so it will be deleted automatically after this time. That's a real-life example from the real-life story of one of our customers. I won't call the name, but it's a real story. So they wanted to keep this data over many years, and we decided not to apply TTLs, but use bucketing. Bucketing is a great approach. What's really solves this problem. A team asks sensor ID reported that makes it unique. No, it makes it unique. But partitioning is defined not on the primary key level, but on the partition key level. And the partition is sensor ID only. That's a clustering column. So what did we do and how do we solve this problem? It's called bucketing. We introduce one more field here, month, year. So sensor ID, UUID as before, timestamp value as before, by month, year, integer or string. So month, year, in this case, it's September of 2021. So it will be 09/2021. Next month, it will be October. So it will be 10/2021. What does that mean? By introducing month, year into our partition key, we make compound partition key, which consists of sensor ID, which never changes per sensor, and month, year, which changes monthly. As a result, every next month partition key will be different, token will be different, and new partition will be created based on that. Well, then problem is solved. Every new sensor created, every new sensor partition created every new moment. And then finally, is there any problem with growing partitions? Cassandra is good on scaling, right? Take a look. Avoid hot partitions. If you are selling your good in the Europe, and Europe has a lot of smaller size countries, you can partition your data per country. But if you, let's say, start to sell in China and you are extremely popular in China and everyone buys from you, first of all, congratulations, you are successful. But from another point of view, you have 10 servers, replication factor free, and European countries are buying not too much from you, so those partitions will be not affected too much, European partitions, but now you have one huge partition for China, right? And it will be accessed all the time, and those free servers will be overloaded. You say, okay, now I have money. So what? I will buy 100 more servers, throw it to a cluster. I will be good. Will you? No. Why? Because still replication factor free servers responsible for which partition. You can add 100 servers, 1,000 servers. That won't help because you still have the same amount of servers responsible for this partition. The partition by data model is unscalable. So avoid hot partitions and avoid growing partitions. With growing partitions, you will have too much data per server and cluster will be slow. With hot partitions, cluster will be not scaling as well as you think. Cluster won't be scaling at all. Cassandra's highest performance is a shared responsibility. There is no magic button, do it good, and Cassandra will do. You have to understand what you are doing. Again, on the scale from bike to Boeing, Cassandra is a Boeing. You need to know what you are doing, or you will crash, or you will have crash landing. And that may be quite bad experience. Yeah, so it will be unbalanced. So think of a balance. Now, we have to skip those because we have to go for certification. You are not ready to use Cassandra right now. Go to the academy.datastax.com and get your certification voucher. There are two certifications for administrators and for developers. As you attended this workshop, you get your vouchers for free and you will pass this exam for free. Now I'm switching to main team. Get back to main team. Get back to main team. And meanwhile, I will get my link for you for the certification. So jump back to main team. And that is the link, copy link, Bart, where is it? Chat. Okay. I will send you a link to the certification voucher.
Perfect.
Yep,
got it. You. Yep.
Good. So we are ready to jump back finally. So now let the battle commence. Now you have to answer fast. I hope you're ready because I'm ready and we are getting out of time. So we will have to be very, very quick. We have 13 questions and you won't have enough. You won't have a lot of time. So 6 people, jump in. 10 more seconds and we start. You have to answer fast, but you have to give the right answers in the same time. So it's the same Menti. I hope you didn't quit.
9, 4, 2, 5.
So we start. Okay. So answer fast to get more points. How many master nodes does Cassandra need? At least 3 per cluster. 3 per data center. Not a single one. Cassandra is decentralized. Enough to maintain consistency. And looks like most of you made it. Not a single one. Cassandra is decentralized. That's the right answer. Now take a look. Today, YouTube has a very huge latency to real life. I am expect at least 10 seconds. So please watch your phones or whatever you use to open Menti. Focus on Menti, not on YouTube, because video stream will be delayed a little bit. I'm sorry for that. So let's move on. Who was the fastest one? Abhijit Ganesh was the fastest one, and that's a great result. But let's move on. Joe, I'm sorry, I don't know what's wrong with the Menti. Normally it works well, and I see people are connected. So that's going to be question number 2. Answer fast to get more points. How data is being distributed? By partitions. Data is replicated to each server with address locators using postmail. Oh, I hope all of you will give the right answer. It's a simple one and time is up. Most of you did it right. Data is being distributed by partitions. Answer is all data is replicated to each server is completely wrong for a simple reason. Companies like Apple or Netflix handle hundreds petabytes of data. Can you imagine copying hundreds petabytes of data to each server? That would be stupid. So Cassandra doesn't do it. Cassandra is not stupid. And the fastest answer is done by, hey, Hemantha Srinivaskota was the fastest answer. And only Nima in Purneswar gave 2 right answers in a row. That's a good result. So we are getting to question number 3. And answer fast to get more points. How to scale Cassandra cluster? vertically upgrading servers, increasing scaling factor, horizontally adding more servers. Don't scale, Cassandra performance is always enough. So, how do you scale Cassandra cluster? Time is up, and the right answer, horizontally adding more servers. Someone was too late on this class, I believe. Yes, horizontally adding more servers. That's right. And what's going on the leaderboard? Purneswar makes a mistake, and fastest answer was by Abhijit Ganesh. Congratulations. And Nemo takes the first place. So far, so good. Let's go. Question number 4. Answer fast to get more points. Which replication factor is recommended? 1.5, 3, 15, 42. So that was discussed in the beginning of our session. Which replication factor is recommended? Team Vanderkeer, that's a good performance. So all of you gave the right answers. Obviously, there is no thing like 1.5 replication. It's technically not possible. And 15 or 42 will be too much. So indeed 3. Now, okay, Hamantha makes a mistake or failed to answer on time. Maybe, I don't know. Fastest answer was done by Purneswar, which wants to return back to the top 3. Only top 3 places are getting the prizes. And Nemo still holds the first place. Question number 5. Answer fast to get more points. Cassandra cluster can be deployed on AWS only, any combination of cloud providers and on-premises DCs, only one cloud provider of your choice, Sega Mega Drive. Hemantha, site is not loading. I'm sorry. I know what it happens with some of our attendees sometimes. Normally it works good. So right answer is any combination of cloud providers and on-premises DC. And I haven't seen Cassandra on Sega Mega Drive so far. So leaderboard is interesting. This time it's getting better, but Nemo was quite slow. And Abhijit was the fastest, taking over and getting first place. That's a competition, ladies and gentlemen. So question number 6. Answer fast to get more points. Cassandra cluster can have multiple data centers. Correct. All DCs are available for read and write, so active. Correct. Some DCs are only for read, so passive. Correct, but not more than 2 DCs. Wrong. Single cluster can be deployed only on one single DC, data center. Right. All data centers are available for read and write, multiple active data centers. And that's a great feature. And it's native feature, moreover. So who was the fastest this time? Oh, okay. Joe was the fastest, getting to the second place. That's a great result. And Neo is now out of top 3. Oh my, that's interesting. So question number 7, and answer fast to get more points. CAP theorem claims what in case of a failure, C, A, and P are all guaranteed. Only A is guaranteed. Only 2 of 3 capabilities are guaranteed. CAP theorem claims what we will need in UCAP. So 9 people have answered it already, and that's a good result. Time is up, and it looks like most of you made it. CAP theorem claims what only 2 of 3 capabilities will be guaranteed. So who was the fastest this time? Fastest is, yeah, team. I'm sorry, but that decreases your chances to stay in top 3. So Abhijit made it, and that's the fastest answer. Well done. Question number 8. Answer fast to get more points. Recommended way to reach immediate consistency is read-write 1-1, read-write 1-all, read-write quorum, or with a video chat. What is the recommended way to reach immediate consistency? I have some interesting questions for you. So read, write, quorum, quorum is the right answer. Read, write, 1-1 doesn't give you immediate consistency at all. And read, write, 1-0 makes it, but it's not a recommended way. So leaderboard, that's quite good. Then question number 9, and I'm starting immediately. So answer fast to get more points. What is a key space? Key space is organized into rows and columns. It contains tables and defines replication. It's defined with partition key and contain rows. It's a place to store keys. Meanwhile, Bart.
Yes.
I believe we are out of time, so we can stop at this moment.
Okay.
Or I can ask a few more questions if we have the time.
I really do got to drop, so if we can wrap it up as soon as possible, yeah.
Yeah, we have to pay respect to our events and our event attendees. So that was the last question, and our time is over. And now, ladies and gentlemen, get ready to see the final leaderboard. And the final leaderboard looks like that. Oh, it was quite a wipe. Okay. So Joao was the fastest this time, and it was enough to bring him to the top 3. Purneswar takes the 2nd place, and Abhijit Ganesh takes the 1st one. Now, please, leaders, make a screenshot of your, or photo or whatever, of your screen at the moment and send it to me at alexander.volochnev@datastax.com, and I will, yeah, that's the right address, and I will make sure what your prizes will be delivered. We deliver worldwide. Thank you so much for staying with me today. And if you have any more questions, I hope you do, you can reach me on LinkedIn, and I will be able to invite you to the next workshop, or we will see what I can do for you. And at this moment, we are done. Thank you, Bart, and thank you, everyone, for being with us.
Thank you, Alex. I think we were all saying in the chat, we got to figure out what we're going to do part 2. Had great interactions, folks answering questions, asking questions. We got a lot of knowledge out of this. Well, there's going to be a summary coming out in a couple of days from some different folks that we're gonna write about this. I think this is a great educational opportunity, and now got some definitely excited new Cassandra fans out there. So really, really appreciate you giving your time with us today.
Yeah, thank you so much. Thank you so much. And it was a great day.
Very good.
Enjoy.
We'll be talking to you soon. Thanks a lot, Alex. Take care.